In this video, we introduce our work, Target-Driven Visual Navigation in Indoor Scenes using Deep Reinforcement Learning. We develop a deep reinforcement learning algorithm based only on visual input to navigate in a space to find a given target. Training deep reinforcement learning methods in the real environment is often infeasible due to their demand for time and data. Hence, we train our algorithm in a simulated world and later adapt it to the real world. We developed one of the first simulation frameworks with high-quality 3D scenes called AI2 Thor. Our framework enables a rich set of physical interactions with objects. The agent can navigate in the environment, apply forces to objects, and change their state. Standard deep reinforcement learning methods take only the observation as input. Therefore, they need to be retrained for new goals. In contrast, our deep reinforcement learning model learns a function of both the current observation and the target. Hence, it eliminates the need for retraining for new targets, which results in generalization across targets and scenes. This is a training episode for the task of finding a sofa. The model initially performs a random walk. In the top right corner, you see a bird's eye view of the scene. The model gradually converges as it observes more frames during training. Here is the final result of our model. Here is another example that shows navigation toward books. Our deep reinforcement learning model learns to navigate to new targets that are not used during training. We also show that the model can navigate to find targets in a new scene. We also show the extension of our model to continuous space. This involves physical interaction and handling noisy movements. We also show that the model that is trained in a simulated environment can be used in a real setting after minimal fine-tuning. We move the robot in the scene and collect images for fine-tuning the model. We specify the door as the target, and the robot learns to navigate to the door. On the right side, you can see a view of the robot. Here is another example that shows navigation toward the microwave. For quantitative evaluations, please refer to our paper.